What we can do is we have these light values. So here's a lot of yellow light, here's a bit less yellow light. So every vertex we can say like, okay, the artificial light that we have is coming from this lamp. We want to have a vector that's kind of like where I'm standing right now, pointing towards this lamp, saying like light that is in this spot where I'm standing currently is coming from this lamp. Let's first get an initial thing going and then we can refine it. So we already have this lighting information. If you take a look at what the information we have per vertex, we have the vertex lighting, vertex material, material map coordinates, normal maps, the fog. So we kind of want to add a new vector here, which we would call like vertex lighting direction. We only need XYZ, but let's fake it first. That's what I learned. We're going to fake it first. This is an overview of how the rendering engine works. We have the game, right? This is where we start. The game, it's got a rendering engine. The rendering engine has got client chunks. These are 32 by 32 by 32 parts of the game world. Voxel information is stored in these client chunks. They have render buffers, and the render buffers contain render vertex instances. So let's call this a standard vector of render vertex. These render buffers are generated from geometry. Meshes. Let's say the client chunk, it's got geometry, it gets meshed, and that's a series of model vertices. So that's a vector of model vertices. Those get converted to like render buffers with render vertices. That goes to the GPU. That goes to the vertex shader, and that goes to the fragment shader. You are here. This is what we've been looking at the entire time, the fragment shader. So this is ultimately what pixels look like on screen. There's a lot of things, a lot of steps that happen before this. We're going to have to change all of these steps, or at least up until the geometry, I think. Geometry gets meshed, and it's a concept I call beautifying. So we generate mesh, and then beautify the mesh. Beautifying is the process where we calculate the in-game world properties of a vertex, set them in the model vertex, that gets shoveled to the GPU en masse. We're going to have to do all of these things in a different way now, because we want to have directional lighting in the fragment shader, so it has to be supplied from the vertex shader. Let's just call this GPU vertex shader, GPU fragment shader. And let's remove this step. So we have to get that information, the information all the way from about here to here. So we're going to have to change about 7 steps or so in the game engine and in the entire pipeline. What we're going to do is to stub out these values. So we're going to fake everything at each higher level. So we start here. We're still going to start with the fragment shader, the part that we've been editing. We start there and we just start with fixed values. We're going to emulate that the light is actually coming in right from the top. Just like the sun has got its position, every bit of light is coming in from the top. Then we can actually see what it looks like in real life. And then all the way down, we're going to start calculating the actual values, the actual directions of the light, up to the point where we say like, bam, this is it, this is perfect. The game, we're probably not going to touch too much. The render engine, we have to touch just a few parts because we have to shovel a bit more data left and right. Client chunks, we're going to have to change some of the lighting information that's stored there, because right now it only contains the light values at all spots, but not the direction of the light. While rendering the meshes, like generating and beautifying, we're going to have to take this lighting information and push it inside of these model vertices. So that's what it's going to result in. Then we'll have to do a bit of work in the render buffer to make sure that these render vertices include this new lighting information and actually calculate it and contain it in the right way. And then we're going to start with these vertex and fragment shaders. Vertex shader kind of ties into the render engine because this communicates with that. We already have the lighting information here, so we're going to fake data all the way up the stack. Starting off with the fragment shader. Instead of adding a new thing already, we're going to fake a lighting direction right here, right now. This is where the sun is being calculated. So this is the reflectance equation. This LO, you can actually add terms to this. So this used to be a loop. This used to be a for loop for int light index is 0, light index is smaller than light count, light index plus plus. So this is kind of like what the loop would look like, and then for every light it would calculate these values and add them up. So that's the entirety of the direct light that's coming in on the material going towards the eye of the viewer. So this is the reflectance equation. Let's call it the sun. reflectance equation. Let's copy this entire thing. And now the artificial light. We already have LO, so we're not going to do anything with LO here. We're just going to add at the end of this. This should compile and run, but this should double the light coming in from the sun, because we do the sun calculation twice. Already you can see this dude is now over bright. The sun is definitely working and it's not doing anything else. So L is the direction where the light is located. We're going to make this a vector of 3. 0 on the x-axis, 0 on the y-axis, and we're going to say like it's coming in straight from the top. Z is up in this engine. So we now should have 2 suns, sort of, because we have the actual sun and the fake sun. There is a light actually right below us. See this? This white spot? It actually follows us around. Light is coming in straight from the top. Then it normalizes a view vector. So view vector is V. It's the vertex position in the world. Or on the main screen, it is facing right towards you. Okay, that looks good. And then the radiance. It says it's the scale of the radiance, which is just kind of like a sun scaling factor. We should rename this. Where is it? Scale PBR sun. Let's call this sun, like this. And let's make sure we only do it for the sun. So that's kind of like the scale of the intensity of the sun. And right now we're going to just tweak with this and let's say, okay, we want to debug this. So let's make this 8.0 even brighter than the sun. The color itself is not the color of the sun, because that's not what we want. We want this to be the local artificial light color. So it looks like we're going to have to calculate that a little bit earlier here. Like this. Artificial light reflectance equation is it's all good, but let's calculate the artificial light first. So we're going to use that color. So for now, like in the village, it's going to be all yellow sort of. And we don't have to remove light if it's in the shadow. Since we don't shadow per light, we're just going to make these always light. And you see this in commercial engines as well. Not all of these dynamic, so kind of like dynamic lights, have proper shadowing. I think all of these other terms, like all of this other calculation stuff going on, like this part, it's actually the same for all of the lights. The only thing that changes per light is the direction the light is coming in from, then the bounce into the eye, and then the color of the light. So I think we're good. Okay. I can see some artificial light here on this grass coming in from the top. So maybe we can even disable the sun. How is that? We disable the sun, we make the artificial light a lot stronger. You can definitely see that there is artificial light being cast. And like the closer we get, the more intense it is. Yeah, this lamp is reflecting here. Check this out. Every individual light now has this reflection thing going on. Let's make it even brighter. Here, these are the highlights we're looking for. And they're near the lamp. But all of these specular highlights that you see, they are now coming from the lamp. So this is supposedly fake light coming in from the top, from a lamp that you can't see. The theory holds. I'm even amazed that the lamp, like the effect is measurable up until here. So now we're going to make this dynamic. Let's use the smallest amount of data possible. Let's say vertex lighting direction. We're going to make it dynamic now and say the light direction is now vertex lighting direction. Sounds cool, right? This won't compile because it doesn't link the inputs together. So now we're going to have to open up the vertex shader. The vertex shader passes data towards the fragment shader. The vertex shader is kind of like the thing that runs for every vertex in the input, and then the fragment shader runs for every pixel in the output. Now we're going to say vertex lighting direction is a vector 3 of 0, 0, 1. This should compile, this should run. But now at least we moved the fixed definition over to the vertex shader. So we're passing along more data and it still works. Now we want to pass this over to the engine. So instead of having it fixed inside of the vertex shader, we now move it to the render buffers inside of the game engine. And that's going to be a bit of a heftier change. We're going to see what that entails.